Okay, before we start today, there are a few questions from yesterday we need to go through, because when I looked at the result of the quiz yesterday, I found out that only half of the students got that right. So I think I should go these questions first before we go on. So there are only 3 questions I will go through from the quiz. First question is this one, which only 48% of you got right. So both of them are actually displacement. 2 of the 3 questions I will go through are from the displacement values. So one of them is this one, which is a little bit complicated. Okay, have a look at this question we had in the quiz. The patient is using drug A, eye drops 0.1% weight by volume for eye infection. So I'll switch just between. So patient is using eye drops, which is 0.1% weight by volume. And then we have the information that he uses 1 drop in both eyes twice daily. So that means this patient, in one day, this patient is using 4 drops in total, right? 1 drop in both eyes for twice a day. So 4 drops in total in one day. And we have to find out in milligrams how much the dose this patient receives, okay? So this patient is taking 4 drops, and we know how many mils are there in 1 drop. Come on, we went through yesterday. No, 1 milliliter has 20 drops. So 1 drop will have 0.05 milliliters. Okay, so this patient is using 4 drops, so 4 times 0.05 is, so this patient is actually taking 0.2 mils. Okay, so basically what's happening is that I know I have to find out in milligrams how many milligrams the patient is receiving. That's what I want to find out. What I know is that the patient is receiving 4 drops. So I converted that 4 drops into mils first, that this patient is receiving 0.2 mils. And now I will find out further how many milligrams are present in this 0.2 mils. Everybody with me? Okay. So how would I find that out? I would find that out from this concentration. So I know 0.1% weight by volume means 0.1 grams in 100 mils. 0.1 milligrams means in 100 mils, that means 100 milligrams in 100 mils. The patient is receiving 0.2 mils. So if 100 mils has 100 milligrams, 0.2 mils will have 0.2 milligrams. It's the same. The answer was 0.2 milligrams. Okay, so everybody with me, we had to find out how many milligrams we had to find out how many milligrams the patient was receiving, but we knew that the patient was receiving 4 drops. So I converted drops into milliliters first, and then I found out how many milligrams are present in this milliliters from this concentration. Everybody understand that? Okay, move on. The next question was displacement value. The 2 questions were of displacement value. So you can see a vial containing here 500 milligram of methylprednisolone for reconstitution. What is the displacement value of methylprednisolone, given that 9.5 when added to the powder produces 50 milligram per mil of the concentration. So as I said before, that for the displacement value calculations, you need to visualize that what's happening here. Okay, that makes things easy. So we have, say, this is a methylprednisolone vial, and it's 500 milligrams. There is a powder which is 500 milligrams, right? Now, when you dilute it, when you reconstitute it, then the concentration of the final solution becomes 50 milligrams per mil. That's the concentration of the final solution here. And in the question, we have also been given the that how much still oil water is added. So we reconstituted it with 9.5 mils. Okay, this is the information we have been given, that you have a powder which you have to reconstitute 500 milligram. You reconstitute it with 9.5 mils so that the final concentration becomes 50 milligram per mil. So this is the information we have been given. Now what we have to do is to first find out what is the actual volume present here. We have only been given the concentration, but the drug here should be 500 milligram because this is 500 milligram. In displacement value calculations, I said that the amount of drug remains the same. So amount of drug 500, amount of drug should be 500 here. So if it's 50 milligram is present in per 1 mil, 500 milligrams will be present in 10 mils. Okay, so that means the final volume of the solution after we reconstituted it with is 10 mils. Right? So what should be the displacement value? 0.5. Because we added 9.5 and we ended up with 10 mils. So the displacement value is 0.5. But this 0.5, as I also said, that displacement value also depends on the amount of the drug. So this displacement value is for 500 milligrams. Okay? So this displacement value is for 500 milligram because we are dealing with a 500 milligram drug, right? But the question is asking for the displacement value in milligrams. Sorry, the displacement value, the question is asking in grams. So basically the question is asking what would be the displacement value for 1000 milligrams. So you just have to double this. And that would be for 1000 milligrams. Everybody with me? And the answer was 1 here. 1 mils per grams. Okay? Everybody understand that? Yes. Okay. The last question from yesterday, which I want to go through, is a little bit complicated, which is again a displacement value. Okay, what volume of diluent? Again, you need to visualize what's happening. What volume of diluent is needed such that when added to 80 milligrams of drug X, it produces the concentration of 4 milligram per mil. So again, it's the same thing. Just imagine this is a vial. Here we have to find out the volume which we will use to reconstitute. And the drug powder is 80 milligrams. And what else information? It produces so when we dilute it or reconstitute it, it produces the final concentration of 4 milligrams per mil. Right? And what else have we given? The displacement value is given as well for 40 milligrams. Okay, but let's do this first. So the final concentration is 4 milligrams per mil. But what would be the final volume here? Let's see this, because I said 80 milligrams we started with, so here it should be 80 milligrams as well. So if 4 milligrams is present in 1 mil, 80 milligrams will be present in. I'm doing the same thing which I did here. The same thing which I did here in the previous question. So for the final volume, I'm only given the concentration, but I want to find out the actual amount of drug and the actual amount of fluid. So if 4 milligrams is present in 1 mil, 80 milligrams will be present in 20 mils. So I know now that the final volume after I reconstitute it is 20 mils, right? And so there are two things missing here. One is this, and one is the displacement value, right? But in the question, displacement value is given, which is 0.5 for 40 milligrams. So the displacement value given in the question is 0.5 for 40 milligrams. But we are dealing with 80 milligrams. So just double this. So the displacement value here is 1, right? So I know the final volume is 20, displacement value was 1, so I should start with 90. Everybody with me? So 19 was the correct answer.